Okay, this is the second Schmidt tutorial. The layout of the screen you should recognize. I've got the file browser and the SSH terminal into the Cologne website set up. And I also have the README file that I also have it open on the screen. And on this section, we've already done this tutorial 1, which created the UTF-8 version of the file from Thomas, which is the original data for Schmidt. Now it's convenient to copy this into another file, sch.txt, which will be worked on by other things in a moment. So that's what this copy statement does, and I've already done it, as you can see in the file browser under the original directory. The first thing I need to do before I can do anything is to recognize what the head words look like. And the way to do that is to look at the Schmidt data, this Schmidt original UTF-8 text file, and just ponder it. And it's actually pretty easy for Schmidt. This is a sample which I copied over into the README file. And you can see there's two forms of every head word apparently. The first form from this example you can see is in Harvard Kyoto, and the second form is in this anglicized Sanskrit encoding. It ends with this vertical bar. The second form has things like this little continuation or some kind of symbol, whereas the first form has those weeded out. So I express this in the form of a Python regular expression and put it in a Python program snippet that can be used elsewhere. So what we're going to first do is examine. The first thing I like to know is what are the characters in this file. So that's what I mean by check EA, extended ASCII. When I run this program, which I've already run just a moment ago, it creates a file which summarizes the extended ASCII characters that are in this file. So I'll go over here to PyWork and just open that up for a moment so you can see what it looks like. Check ea.txt. And it says there were 21 AS, that's a typo, should be EA. Instances found, and it then shows each of those instances, number 1, number 2, and so forth down through number 21. And for each of those it gives a summary line saying how many times it occurred. This is what the Unicode character is, and this is the name of the Unicode character, which is useful. And then it gives 10, if there are that as many as 10, it gives the first 10 lines in which that occurred. So this broken bar we know occurred a whole bunch of times because it's in all the head words. So that's what that means. Now it's convenient to print out these summary lines, and that I can do with just a grep on that colon equal, which is part of the line, and pipe that out to a temporary file. Then I'll look at the temporary file, open it up. See, it's got 21 lines as expected, and here's all the extended ASCII characters. I'll copy that over and paste them into this file. At the moment we won't worry about exactly what function they serve. The only one we've really examined is this broken bar, which ends a head word section. But this is useful to have. I'll change this to do to done and keep going. Now I want to do a similar kinds of thing we can see from the file. We'll look at the Schmidt original file. that there's lots of anglicized Sanskrit coding of Sanskrit using letters and numbers to designate Sanskrit. This is probably represented in the scan. We'll look at that sometime later as Roman Unicode. What is like an M with a dot under it, an S with a little grav accent, and so forth. And so we want to find out what are all the things like that in the file. That's what this next step is about. So that's check AS. So again, I run this Python program to get a summary, just very similar to before, of this check AS. I won't rerun it, but I'll just look at the output with you briefly. And this has, for example, capital A1 is the first one. It occurs 1131 times. It's the same, it's a coding for, it's known to be a coding for a capital A with a macron. This is Unicode for that thing, and this is a Unicode description of that. Some of them are not yet described. These, I don't have the correspondence yet described. So that'll be something that'll need to be done sometime, but not right now. So again, I can get these summary lines. I do want to have them in the file by grepping on this colon equal in that file. So I'll grep into check_AS and then copy and paste that information from into the README file. And again, there's more work to do here because there's quite a few that don't have descriptions yet. Some of them, well, we'll just have to see how these should be handled. Some of them might be errors. For example, K2 maybe is an error. It only occurs one time. Don't know at this stage. But it's useful to have this for, and again, from the check AS file, we can find examples and compare them with the scan at some point. Now the next kind of coding, I just want to know what kinds there are. Thomas uses curly somethings to indicate certain typographical features of the text. And so I want to see what kind of curly notation he uses. So that's what check curly does. I've already done check curly. And here it's let's just look at the output which was done a little while ago. Actually, there's only 7 forms of it. By grepping and so forth, I made this summary of it. And I know from previous experience with this that these curly pound signs represent Devanagari text coded in HK normally, although in our example he codes at least the full form of the head words, but codes it in anglicized Sanskrit. The curly percent is normally used to indicate italic codes, and probably from these examples, just looking at the file, probably it's not only in italics, but it's also in it's also Sanskrit that is in italics. This dot 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 symbol, by the way, was inserted by Thomas for some reason to indicate that this was a grouping, although the curly percent seems to do the same job in this case. So there's a couple of problems here. We'll have to solve them sometime. But again, right now we're just surveying the situation. So we'll go on. Also, sometimes there are angle bracket tags in the file. So that's what this sort of pseudo XML, that's what this stuff does. But in this case, I ran this program and there weren't any. So that's nice. Don't have to worry about that. And the last thing to do is to check how the page numbers are represented. They're almost always in his digitizations in the form square bracket, PAGE, and then something, and then close square bracket. The exact part here, which we'll have to see if that's always what's if this is that we see here is exemplary of it, and that's what the purpose of this check page test is. And if we look at the check page file, which looks a little different than the others, check page text, we can see that it looks like it's mostly the same. Here's a different situation. We'll have to understand what this is about, this page. So these are probably page and columns. And then this is something else. Why is that A there? Not sure. So this file just records what they all are because we'll have to understand that later. So I'll mark that one as done and end this second tutorial.